Mark, my name is Tinson. My student number is 5. Hi Mark, my name is Tinson. My student number is 56. I'm a freshman in NCUE. Just Iliff. One more reason to get a good night's sleep. Sleep is something we spend about a third of our lives doing. But do any of us really understand what it's all about? 2,000 years ago, Galen, one of the most prominent medical researchers of the ancient world, proposed that when we awake, our brain's motive force is juice will flow out to all the other parts of the body, and melting them by leaving the brain all dried up. And he thought that when we sleep, all these molecules that fill the rest of the body will come rushing back, rehydrating the brain and refreshing the mind. Now that sounds completely ridiculous to us now, but Galen was simply trying to explain something about sleep that we all deal with every day. Since we all know based on our own experience that when you sleep, it clears your mind, and when you don't sleep, it leaves your mind murky. But while we know a great deal more about sleep now than when Galen was around, we still have not understand what it is that sleep, of all of our activities, has this incredible restorative function for the mind. So today I want to tell you about some recent research that might shed new light on this question. We have found that sleep may actually be a kind of elegant design solution to some of the brain's most basic needs, a unique way that the brain meets the high demands and the narrow margin that set it apart from all the other organs of the body. So almost all the biology that we observe can be solved of a series of problems and their corresponding solution. And the first problem that every organ must solve is a continuously supply of nutrition to fuel all those cells of the body. In the brain, that is especially critical. Its intense electrical activity uses up a quarter of the body's entire energy supply. Even so, the brain accounts for only about 2% of the body's mass. So the circulatory system solves the nutrient delivery problem by sending blood vessels to supply nutrient of oxygen to every corner of our body. You can actually see it in this video here. Here we imagine blood vessels in the brain of a living mouse. The blood vessels from a complex network that fill the entire brain volumes. They start at the surface of the brain and then they dive down into the tissue itself. And as they spread out, they supply nutrient and oxygen to each and every cell in the brain. Now, just as every cell requires a nutrient to fuel it, every cell also produces waste as a byproduct, and the cleanliness of that waste is the second best problem that each organ has to solve. This diagram shows the body's lymphatic system, which has evolved to meet this need, is a second parallel network of vessels that extend throughout the body. It takes up protein and other waste from the space between the cells. It collects them and then dumps them into the blood so they can be disposed of. But if you look really closely at this diagram, you will see something that doesn't make a lot of sense. So if you were to run into this guy's head, one of the things that you will see there is that there are no lymphatic vessels in the brain. But it doesn't make a lot of sense, does it? I mean, the brain is this intensely active organ that produces a correspondingly large amount of waste that must be effectively cleared, and yet it lacks lymphatic vessel, which means that the approach that the rest of the body takes to clean away its waste won't work in the brain. So how then does the brain throw its waste cleanness problem? Well, that simply modern question is where our group first jumped into this story, and what we find as we dove down into the brain. Down among the neuron and the blood vessel was that the brain's solution to the problem of waste cleanness was really unexpected. It was ingenious, but it was also beautiful. Let me tell you about what we find. So the brain has this large pool of clean fluid called cerebrospinal fluid. We call it the CSF. The CSF fills the space that surrounds the brain, and the waste from inside the brain may layer well out to the CSF, which get dumped along with the waste into the blood. So in that way, it sounds a lot like the lymphatic system, does it? But what's interesting is that the fluid and the waste from inside the brain, they don't just percolate their way randomly out to this pool of CSF. Instead, there is a specialized network of plumbing that organizes facilitates this process. You can see that in this video here. We are again imagined into the brain of living mice. The frame on your left shows what's happening as the brain surface, and the frame on your right shows what's happening down below the surface of the brain within the tissue itself. We have labeled the blood vessel in red, and the CSF that surrounds the brain will be in green. Now, what was surprising to us was that the fluid on the outside of the brain, it doesn't stay on the outside. Instead, the CSF was pulled back into and through the brain along the outside of the blood vessel, and as it flashed down into the brain along the outside and this vessel, it was actually helping to clean the waste from the space between the brain cells. If you think about it, use the outside of this blood vessel like this is really clever design solution, because the brain is included in a rigid skull, and it's packed full of cells, so there is no extra space inside it for a whole second set of vessels like the lymphatic system. Yet, the blood vessel that extends from the space from the surface of the brain down to reach every single cell in the brain, which means that fluid that's traveling along the outside of this vessel can get easy access to the entire brain volume. So it is actually this really clear way to repurpose one set of vessel, the blood vessel, to take over and replace the function of a second set of vessel, the lymphatic vessel, to make it so you don't need them. And what's amazing is that no other organ take quite this approach to clean away the waste from between its cells. This is a solution that is entirely unique to the brain. But our most surprising finding was that all of this, everything I just told you about, with all this fluid rushing through the brain, is only happening in the sleeping brain. Here, the video on the left shows how much the CSF is moving through the brain of a living mouse. When it's awake, it's almost nothing. Yes, in the same animal, if we wait just a little while until it's gone to sleep, what we see is that the CSF is rushing through the brain. And we discovered that at the same time, when the brain goes to sleep, the brain cells themselves seem to shrink, opening up space in between them, allowing fluid to rush through and allowing waste to be cleaned out. So it seems that the Galen must actually have been sort of on the right track when we wrote about fluid rushing through the brain when sleep came out. Our own research now is 2,000 years later suggests that what's happening is that when the brain is awake and is at its most busy, it's put away cleaning away the waste from the space between its cell until later, and then when it goes to sleep and doesn't have to be as busy, and it shifts into a kind of cleaning mode to clean away the waste from the space between its cells. The waste accumulated throughout the day. So it's actually a little bit like how you or I, we put off our household chores during the work week. When we don't have time to get to it, and then we play catch up on all the cleaning that we have to do when the weekend rolls around. Now, I've just talked to a lot about waste cleanliness, but I haven't been very specific about the kind of the waste that the brain needs to cleaning during sleep in order to stay healthy. The waste product that these recent studies focus most on amyloid beta, which is protein that's made in the brain all of the time. My brain's making amyloid beta right now, and so is yours. But in connection with Alzheimer's disease, amyloid beta build up and aggregates in the space between the brain cells instead of being cleaned away like it's supposed to be, and is the build up of amyloid beta that's thought to be one of the key steps in the development of less terrible disease. So we measure how fast amyloid beta is cleaned from the brain when it's awake versus when it's asleep. And we find that indeed the cleanness of the amyloid beta is much more rapid from the sleeping brain. So if sleep, then it's is part of the brain's solution to the problem of wakefulness, then this may dramatically change how we think about the relationship between sleep, amyloid beta, and Alzheimer's disease. Alzheimer's disease. A series of recent clinical studies suggest that among patients who haven't yet developed Alzheimer's disease, worsening sleep quality and sleep duration are associated with a greater amount of amyloid beta building up in the brain. And what it is important to point out that this study doesn't prove that lack of sleep or poor sleep cause Alzheimer's disease. They do suggest that the failure of the brain to keep its house clean by cleaning away waste like amyloid beta may contribute to the development of conditions like Alzheimer's. So what this new research tells us then is that the one thing that all of you already knows about sleep, that even Galen understood about sleep, that it refreshes cleans the mind, may actually be a big part of what sleep is all about. See, if you and I, we go to sleep every single night, but our brain never rests, while our body is still and our mind is off walking in dreams somewhere. The elegant machinery of the brain is quietly hard at work cleaning and maintaining this unimaginably complex machine. Like our housework is a dirty and a thankless job, but it's also important. In your house, if you stop cleaning your kitchen for a month, your home will become completely unlivable very quickly. But in the brain, the consequence of a falling behind may be much greater than the embarrassment of dirty countertops, because when he comes to cleaning the brain, it is the very health and the function of the mind and the body that's at stake, which is why understanding this very basic housekeeping function of the brain today may be critical for preventing the treating disease of the mind tomorrow. Thank you. Applause.